Dear students, I welcome all of you for today's lecture U18 PCAS 701 Guidance and Control. Last class we discussed the root purpose techniques. Today we are moving to design an autopilot system. This is the first thing I said, displacement autopilot. This is simplest form of autopilot, which is the type that first appeared in the aircraft and still being used in some of the older transport aircrafts. So mainly this type of autopilot was designed to hold the aircraft in straight and level flight with little or no maneuvering capability. So this is a block diagram for such a displacement autopilot. This displacement autopilot in this case of, if you used to do to overcome the disturbance it will causes in the pitch motion, then it is called a pitch displacement autopilot. So you see that these are basic components of your displacement autopilot. So this is to be aircraft dynamics, that will be, this is a longitudinal aircraft dynamics. Here we are only here focus is to pitch control, then elevator servo, then amplifier, then vertical gyros. This type of displacement autopilot is to hold the aircraft in steady and level flight. So once your pilot engaged reference altitude, the reference is aligned, then this autopilot will be engaged to maintain a straight level flight. Straight level flight means the aircraft moves with constant velocity as well as constant altitude. So this is called a steady level flight. So this autopilot mainly used to engage your steady level flight. So whenever if any disturbance will be causes, so if a disturbance will be causes, the nose of the aircraft is moves, or because once if a pilot engage steady level flight, they hold to initiate or engage your displacement autopilot. It will hold the aircraft in steady and level flight. So if any external disturbance will causes, therefore this theta will be maybe changed. Okay, because while you engage in a steady level flight, at the time what is your pitch angle is to be your reference. So if there is any disturbance will be causes, if this theta is vary, therefore it will track, it will compare with your reference input through a vertical gyro. This vertical gyro will based on that initiate the voltage. Okay, well, so this voltage is EG is produced from the signal generated at the vertical gyro. Then this voltage is amplified and feed to the elevator servo. So this elevator servo may be operated in electromechanically or hydraulically. Okay. Then this elevator servo, it will initiate the action to deflect your elevation elevator angle to compensate this pitch angle. So based on this, aircraft dynamics will be active. Okay. The main thing is, once if you engage a steady level flight, then a pilot will hold your displacement autopilot. It will hold the aircraft in steady level flight. So whenever any disturbance will be causes, if this theta is varies, then it will sensify this vertical gyro. Then it will compare with your reference. Actually, while in holding steady level flight, what is your pitch angle? That is your reference angle. Then now if any disturbance will be causes, the theta may be varies. So based on that, it will sense, it will compare with your vertical gyro. Okay. This vertical this vertical gyro is will be produce a voltage signal. Then it is voltage signal amplified. Then it is passes through your elevator servo. This elevator servo, it will actuate your elevator. So if you due to this theta maybe causes positive changes, then this will be upward in the elevator, then it will comes to a reference or steady level flight. Okay, so it will counteract this movement caused by your dynamics. This is a block diagram of your displacement autopilot. So while using this displacement autopilot, what are the disadvantages that can be analyzed with the help of two different aircrafts? So here if I put this to be aircraft dynamics, then this vertical gyro is modified into summer. Then this amplifier as well as elevator servo that will made it into servo transfer functions. This is where longitudinal aircraft dynamics. Okay, we are assuming this a short period approximations. Okay, so here I take two different aircrafts while investigating two different aircraft. What are the disadvantages for a displacement autopilot? So the first aircraft is a conventional transport aircraft flying at 150 miles per hour at sea level. The second I took is to be a jet transport aircraft flying at 600 feet per second at 40,000 feet. Okay. While we are putting the displacement autopilot, what is a disadvantage? We'll compare two different cases. So the main thing of your displacement autopilot is to be to hold the aircraft in straight and level flight. So it is not only pitch angle. If there is if change any direction in the heading reference, then we can use a rudder to deflect that one. Therefore, that in this case we are using directional gyro instead of vertical gyro. Okay, so whenever any changes will be occurs, then how it will counteract this effect by using displacement autopilot. We will discuss this subsequent lectures. Okay. So this is where a block diagram of conventional transport and a autopilot system, displacement autopilot system, where is to be gain of your survey. The servo is having a first order system. So with the time constant, maybe this time constant may be very 0.1 to 0.03 seconds. Okay. This is where aircraft dynamic, longitudinal aircraft dynamics. Then these were transfer function for your elevator servo along with the amplifier. Where S is a gain. So here I reference as a aircraft dynamics is to be negative transfer function. Therefore I made it a servo as also negative. Then we will multiple we will get a forward positive transfer function. Then the theta also positive. Maybe it will take the reference. Then we will compare based on that. They will be produce a error. That means based on the error signal, the vertical gyro, it will produce a voltage signal. From this voltage signal, that will goes to your elevator servo. Then elevator servo, based on that, it will initiate or it will deflect your elevator to compensate this theta. Okay. So I take one reference jet transport aircraft. First we try to sketch the route locus. Then we will investigate two different aircrafts. Which one is suitable for this displacement autopilot? Okay. So what is your transfer function? Loop transfer function is to be, if you multiple is, if I instead of s, I make it as a k. You are better understanding. This k is to be gain. Okay. So multiple with this one minus the minus plus, then we will get your transfer function loop transfer function k times s plus 3.1 s plus 3.1, then s into s plus 12.5, then s square plus 2.8 s plus 3.24. I just to multiple these two one, because these two block is to be a cascade block. We multiple, then we will get to a single block. then your reference theta, then it will come some is a negative feedback. This is a theta, then this is a theta reference. So what is your current, your pitch angle, that will compare with your reference, because while holding your straight and level flight, what is your pitch angle, that is your reference pitch angle. If there is any external causes, maybe the aircraft nose up or that they will move on to another theta. We will compare with this theta as well as your theta reference. You will get the error. Based on this error, the vertical gyro, it will initiate the voltage to your elevator servo. Here it is a combined transfer function. As k into s plus 3.1 divided by s into s plus 12.5 into s square plus 2.s plus 3.24. It is your combination of your aircraft dynamics along with your servo. Where k is a gain. We are going to investigate what is how the gain is varies. What is our damping ratio? What is the gain value, and the system is to be stable. If the system, but if we keep on increasing this gain, when the system moves from stable to unstable. So all those things we are going to discuss now. Okay, this is now I have a transfer function k into s plus 3.1 divided by s into s plus 12.5, the s square plus 2.s plus 3.25. This loop transfer function is a unity feedback system, therefore h is to be 1. This is your loop overflow transfer function g of s. G of s equal to k times s plus 3.1 divided by s into s plus 12.5, s square plus 2.s plus 3.24. And try to sketch root locus. What is your loop transfer function g of s into h of s, or h of s to unity feedback? It will be k into s plus 3.1 s plus 3.1 divided by s into s plus 12.5, then s square plus 2.8 s, then plus 3.24. It will be 3.24. This is my transfer function for conventional transport aircrafts while using a displacement autopilot. This displacement pitch autopilot. Here I am going to compensate this pitch angle. So we know that GMV unity feedback system. If we have a transfer function, you try to sketch your root locus. So this will be 0 and minus 1, minus 2, and minus 3, minus 4, minus 5, minus 6, minus 7, minus 3, minus 9, minus 10, minus 11, minus 12, minus 13. So if I am setting my numerator is equal to 0, we will get the zeros. If I am setting the denominator equal to 0, I will get the poles. Therefore the poles are one is s equal to 0, then s plus 12.5 equal to 0, then we'll get s equal to minus 12.5, then s square plus 2.s plus 3.24. While solving this equation, what is the root? S square plus 2.s plus 3.24, this must be equal to 0. While solve this equation, what is my roots? Anyone please tell me what is the roots? the zeros are, I am setting s plus 3.1 equal to 0 because I am setting my numerator equal to 0. I will get the zeros of the given transfer function. The zeros are s plus s equal to minus 3.1. So minus 3 is there, minus 3.1. It is my zeros. The zeros are marked as a small circle. Then s equal to 0 poles marked is in a cross symbol. Then s equal to minus 12.5, this is minus 12, this is minus 12.5 poles. Then if you solve this equation, s square plus 2.s plus 3.24, while solving this equation, what is your roots? Please anyone tell us what is the roots? While solving this equation with s square plus 2.s plus 3.24, if anybody having calculator, please find these roots and tell me. S square plus 2.s plus 3.24 equal to 0. This will be minus 1 is a 1j, 2j, 3j, 4j, 5j. Here minus 1j, minus 2j, minus 3j, minus 4j, minus 5j. So what is the value of roots? Here s square plus 2.s plus 3.24. This is hey, anyone please tell us what is the root value? Calculate it. U18A006.
Sir,
What is the value of roots?
sir, is it minus 1.4 and plus 1.13? I plus or minus?
It is a complex conjugate root.
Yes, sir.
What is your real part? Minus
Minus 1.4
minus 1.4
plus or minus 1.13. I
or minus 1.13 Java.
yes, sir.
Imaginary part. Therefore, 1 poles is minus 1.4 plus 1.13 J. So minus 1.4 is a minus 1. Here minus 1.14. Then 1.13. Here 1. The 1.13 like this. So we become this here 1 poles, then minus 1.4 minus 1.13, then another poles here. So now I find the first step, the poles and zeros of the given transfer functions. Then next we have to find whether this real axis will be participate in the root locus or not. Now can you find out? Then we take some test point. Suppose if I take test point here, the right hand side of this the test point, the number of poles and zeros count is 0. Therefore this portion will not be part of the root locus. Suppose here I am taking one reference point. So this reference point T2, the right hand side of the reference point, the number of poles as well as zeros count. Here I have only one pole lies in a real axis, therefore the count is 1. Therefore this will be part of the root locus. Therefore up to this portion will be part of the root locus. The green line will be part of the root locus. Okay. Then I am taking another one test point here. In this region T3, the right hand side of the test point, how many number of poles and zeros lies in a real axis? The total count is 2 because one pole lies at s equal to 0, another one 0 is lies at s equal to minus 3.1. Therefore the count is 2. Therefore this portion will not be part of the root locus. So here up to here. Then I am taking another test point here T3 as well as T4. If I take the test point T4, the right hand side of the test point, the total number of poles and zeros count lies in a real axis. One pole lies at s equal to minus 12.5, then another pole lies at s equal to 0, then one zero lies at s equal to minus 3.1. The total count is 3. So if it is a odd number, then it will satisfy angle criterion, therefore that point will be part of the root locus. Therefore entire this region up to infinity will be part of this root locus. This region also part of the root locus. Okay, this is step number 2. The step number 1, we have to identify poles and zeros of a given transfer function. Then step number 2, we have to check whether the real axis will be participate in the root locus or not. Okay. Then step number 3, we have to find out angle of asymptotes. Why we have to find out angle of asymptotes? Because all the root locus branches start from poles and it meet at zeros. So in this problem, I have 4 poles. What are the poles? One is s equal to 0, then s equal to minus 1.4 plus 1.13j, then minus 1.4 minus 1.13j, then s equal to minus 12.5. Therefore, I have 4 poles. Therefore, I have 4 root locus branches. But I have only one finite zero. That zero is also s equal to minus 3.1. Therefore, only one root locus branches start from any one pole that will meet at zeros at s equal to minus 3.1. Remaining all root locus branches. So remaining I have 3 root locus branches. Totally I have 4 root locus branches. Out of 4 root locus branches, one root locus branch start from poles and it will meet at zeros at s equal to minus 3.1. Remaining 3 root locus branches start from poles and follow the path of asymptotes and meet at zeros at infinity. Okay. Therefore, I have to find out 3 angle of asymptotes. Angle of asymptotes. Angle of asymptotes. The formula is plus or minus 180 degree to q plus 1 divided by n minus m. We get plus or minus 180 degree. 2q plus 1, where q varies from 0 to up to n minus m. So in this problem, your n is indicates small n indicates number of poles, m is indicates number of zero. I have 4 poles, I have 1 zeros. Therefore n minus m, 4 minus 1, 3. The q values varies from 0, 1, 2, 3. So if you substitute q equal to 0, then 180 plus 1 divided by n minus m, 4 minus 1, I have 3. Therefore I get plus or minus 60 degree. Then if you substitute q equal to, it is 0, when q equal to 1, I get plus or minus 180. Then 2q plus 1, q is 1, then 2 plus 1, 3 by 3, and I am getting plus or minus 180 degree. But I need only 3 asymptotes, because already one root locus branches start from poles and meet at zeros at s equal to minus 3.1. Therefore, remaining 3 root locus branches only start from poles and follow the path of asymptotes to meet at zeros at infinity. Therefore, I need only 3 root locus branches, 3 angle of asymptotes. One is plus or one is plus 60, another one is minus 60. Then I take plus 180 degree. These are the 3 asymptotes. Then we have to find out the intersection of asymptotes with the real axis. It is called as a centroid. So the centroid formula is sum of poles minus sum of zeros divided by n minus m. Sum of poles. So what are your poles? The poles is minus 12.5. Then 0, 0. Then minus 1.4 plus 1.13j, minus 1.4 plus 1.13j, then minus 1.4 minus 1.13j is a sum of poles minus sum of zeros. The zeros is s equal to minus 3.1, therefore minus 3.1 divided by n minus m. Number of poles is 4, number of zeros is 1, 4 minus 1, 3. So your centroid C is equal to sum of poles minus sum of zeros divided by n minus m. What is the value for centroid? Minus 12.5 minus 1.4 minus 1.4, then plus 3.1 divided by 3, get minus 4.06, approximately minus 4.1. This is my centroid. So my centroid is here. This point is centroid. So from the centroid, use a protractor. We measure a plus 60 degree in counterclockwise direction. Then minus 60 degree is a clockwise direction. For your angle of asymptotes, 180 degree positive, 180 degree, then it is measured in anti-clockwise directions. So this will be 60 degree. Therefore, use your protractor. Make a 60 degree. You draw a line. You get line like this. This angle is to be 60 degree. The same way you have to space bottom also. Plus 60 degree, this is centroid C. Then 180 degree asymptotes, it will lies in a negative real axis. Okay, another one asymptotes. Once we find the asymptotes, then if we have a complex conjugate pole, then we have to find out angle of departure. So next step you have to find out angle of departure, as well as you have to find out whether break in or break away points. Then how can you find out break away or break in points? Step to find break away as well as break in point. Find break away or break in point. Okay. So the formula is, we have to find out Walker characteristic equation. The formula is 1 plus g of s into h of s c equal to 0. Then 1 plus, what is your g of s, k times s plus 3.1 divided by s into s plus 12.5 into s square plus 2.8 s plus 3.24 is equal to 0. We just cross multiply, we get s into s plus 12.5 into s square plus 2.8 s plus 3.24 plus k into s plus 3.1 equal to 0. Therefore, your k is equal to, this whole term come to that side minus, so we cross multiply, we get s square plus 12.5s. So s square plus 12.5s into s square plus 2.s plus 3.24 divided by s plus, this whole thing comes to minus s plus 3.1. These were k value. Then if you differentiate dk by ds, then I am setting equal to 0. From that I found the s value. If this, we have some s value, this s I am going to substitute in this given k equation. If I get the k value is a positive and real, then the respective s may be break away or break in point. So in this problem, we don't have any break. So if we differentiate this dk by ds equal to 0, then we find out your s values. So we simply angle of angle. So here I have certain poles. One pole slice here, origin. Then one poles that will be is minus 1, minus 2, minus 3, minus 4. Somewhere it will locate is minus 12.5. Is another pole. What is your complex conjugate pole? So just I find out angle of departure. A complex pole is located uh, minus 1.4 plus 1.13. Minus 1.4. This will be The screen is visible to all of you?
Yes, sir.
Then we have to find out angle of departure. What is your complex pole? The complex pole is minus 1.4, 1.13 J. This here, 1.13 J minus 1.4. And here one pole is there. Here it is minus 1.4. This is 1.1. Then 10 is located minus 3.1. The 0 is what? This is small circle. Okay. Then another pole minus 1.14 minus 1.13 J. Then how can you find out the angle of departure? The angle of departure formula is 180 degree minus sum of angles drawn from other poles to complex conjugate poles. Sum of angles drawn from other poles to complex conjugate poles. Other poles to, I say this is pole number P2. Other poles to poles P2. Then plus the angle drawn from, I mean sum of angles drawn from zeros. Sum of angles drawn from 0 to complex pole P2. So here this is a complex pole P2. I am just find the angle of arrival for angle of departure for this complex pole P2. You draw a vector line from other poles. The red color line indicates the vector line drawn from other poles to complex. This one line, then another one line, then here also one line. So it is measured. This angle is to be theta 1. Then this angle is to be theta 2. This angle is to be theta 3. Then this green color indicates the vector line drawn from zeros to the complex conjugate pole. This is zeros. So this angle I am taking as a theta 4. Okay. Then the formula is to be 180 degree minus sum of angle drawn from other poles to P2. This angle is theta 1, then theta 2 plus theta 3. Therefore, the whole is theta 1 plus theta 2 plus theta 3. Then plus sum of angles drawn from zeros to complex pole P2. That is zeros to complex pole P2. The angle is theta 4. Then this angle is theta 4. Then we have to find out what is the value of theta 1. Suppose if I consider this angle is to be alpha, I take a small triangle, this triangle. If I make it this alpha, this to this line, this to this angle is to be theta 1. This to this angle is to be theta 1. If you add 180 degrees equal to, in this case 180 degrees equal to theta 1 plus alpha. Theta 1 plus alpha is equal to 180. If you want theta 1, then we get 180 degree minus alpha. So how can we find alpha? This is a small triangle. From this point to this point, the distance is 1.14. The height is 1.13. If we put tan alpha, it's equal to 1.13 divided by 1.14. So what is the angle? Alpha is equal to tan inverse of 1.13 divided by 1.14. The angle is 44.74 degree. alpha is equal to 44.74. Therefore, theta 1 is equal to 180 minus alpha. And 180 minus alpha, we get 135.25. 135.25 is a theta 1. Then theta 2 is to be, this is mirror image of this pole, therefore it is lies in a vertical. Then this angle is to be theta 2 is a 90 degree. Then how can you find out theta 3? If you see this point is 12.5. If I consider this is a right angle triangle, this is a right angle. This from origin to this point is a 12.5. If we consider this is a right angle triangle, then up to this distance is 1.5. So we 12.5 minus 1.4. 12.5 minus 1.4, I get 11.1. So 12.5 to up to this distance is 11.1. Again, this vertical height is 1.13. So this angle we designate as theta 3. So again, using tan inverse of theta 3 is equal to tan inverse of 1.13 divided by 11.1. So we can use tan inverse of 1.13 divided by 11.1. You get 5.81. Theta 3 is here, 5.81 degree. Then what is the value of theta 4? If we consider this green color line is make as a triangle. So these zeros to origin, the distance is minus 3.1. But here we want up to this distance. Therefore 3.1 minus 1.4. 3.1 minus 1.4. I got 1.7. So this to this distance is 1.7. This distance is 1.7. Again the height is 1.13. This is a theta 4. So theta 4 is equal to tan inverse of 1.13 divided by 1.7. Tan inverse of 1.13 divided by 1.7. And I get 33.61 degree. So theta 4 is equal to 33.61 degree. 33.61 degree. Therefore, your angle of departure, the formula is 180 degree. Then minus of theta 1 plus theta 2 plus theta 3. The theta 1 is to be 135.25. 135.25. Then theta 2 is to be 90. Then theta 3 is to be 5.81. Then plus your theta 4 is a 33.61. 33.61. Therefore, your angle of departure is to be S 180, then minus of your 135.25 plus 90 plus 5.81, then plus 33.61, and we will get, I get minus 17.44. Therefore, this angle of departure is minus 17.44. So then the same way we have to calculate angle of departure for another complex conjugate pole. This is a P3, this pole P3. It is a mirror image of P2, therefore it is a minus 7.44. Angle of departure for complex pole P2. Then for complex pole P3, it is a value say plus 17.444 degree. Therefore, the root locus branches for complex pole start at the angle of departure. So this case, my root locus branches start from these poles is at the angle of minus 17.44 degree. Then it will start, it will follow the path of these asymptotes, then it will meet at 0 at infinity. So these root locus branches start at an angle of plus 17.4 degree and follow the path of these asymptotes, it will meet at 0 at infinity. While next we have to check whether the root locus branches intersect the imaginary axis or not. Next step, we have to check whether my root locus branches intersect the imaginary axis or not. Then how can we check this one? We know the closed loop characteristic equation. The formula is 1 plus g of s into h of s is equal to 0. Then 1 plus k times s plus 3.1 divided by s into s plus 12.5 into s square plus 2.8 s plus 3.24 and equal to 0. And we cross multiply s square plus 12.5 s square plus 12.5 s into s square plus 2.8 s plus 3.24 into plus ks plus 3.1 k equal to 0. Then we cross multiply s square into s square, we get s power 4. Then s square into 2.s, then we get 2.s8 s cube. Then 3.24 s square and 3.24 s square. Then we get 12.5 s cube plus 12.5 s cube. Then 12.5 into 2.8, 12.5 into 2.8, and I get 35 s square plus 35 s square. Then 12.5 s into 3.24, 12.5 into 3.24, and I get 40.5 s plus 40.5 s, then plus ks plus 3.1 k must be equal to 0. So we add s power 4 here plus 2.8 s cube, here 12.5, so 2.8 plus 12.5, we get 15.3 s cube, 15.3 s cube. Here 3.24 s square plus 35 s square, 3.24 plus 35, 38.24 s square plus 38.24 s square. Then here 40.5 s plus ks, then I take 40.5 plus k, then we take s is outside, then plus 3.1 k must be equal to 0. This is the equation. From that equation, we substitute s equal to j omega. Then we segregate the real part as well as imaginary part equal to 0. Then we find the value of omega that will indicate where the root locus branches intersect the imaginary axis. The k values indicate while the root locus branches intersect the imaginary axis, the respective gain value. If you put s equal to j omega, then we'll get j square omega, then j power 4 into omega power 4. Where j square is a minus 1, then minus 1 into minus 1 we will get positive 1, then we will get omega power 4. Then 15.3 s cube, then we get j cube. J cube we will use a minus j, because j square is a minus 1, therefore minus 15.3 j omega cube. Then 38.4 s square, then we put j omega whole square, then we get j square omega square, the j square is a minus 1, therefore minus 38.24 omega square. Here 40.5 plus k, s is a j omega, then we get 40.5 j omega, then plus s is j omega, k j omega, then plus 3.1 k, then equal to 0. And I am equating that real part as well as imaginary part equal to 0, and the real part is here omega power 4, then minus 38.24 omega square plus 3.1 k plus 3.1 k equal to 0. Then we minus 15.3 j omega, if we setting my imaginary part equal to 0, then minus 15.3 omega cube then here plus 40.5 omega plus k omega equal to 0. I have two equations, then I have two unknowns. If you solve these two equations, I will get omega value as well as gain value. Okay, if you solve this equation, I will get my omega as well as gain value. Okay, what? Then we will check where at which point the root locus branches cross the imaginary axis. Okay, to solve this equation, I will get the k values 77.5. Okay, 77.5. These were k value. This is a gain when the root locus branches cross the imaginary axis. Therefore, it is a limiting value of gain, which will tell us where stability of the system. If we exceed the gain values more than 77.5, then the aircraft becomes unstable. Okay. So if you substitute this k value is 77.5, then we find where omega values. So here omega power 4 minus 38.24 omega square. If you substitute k value here, then we find the omega value. So you try to find out where the root locus branches cuts the imaginary axis always. Okay. If you have any doubt, you can ask me. We will continue in this topic to the afternoon classes. Any doubt?